All right, so for this first problem, I'm gonna sketch my graph on another sheet of paper. So the 8-ball is at 5,5/4. And then it is going to hit at 6, 0, and then bounce away. So I can see that this is forming the shape of an absolute value function. And one easy way to tell is the shape of the graph. All right, so now to come up with the equation, I need to find the slope of this line segment. So I can use the formula for slope. So I'll call this point, I'll call this x2, y2, and I'll call this x1, y1. So substituting those values in, I get 0 minus 5/4 over 6 minus 5, which becomes negative 5/4 over 1, or just negative 5/4. All right, well, that part's the negative portion. Obviously, the positive portion would be positive 5/4. So I know the equation will have 5/4 in it. And then I can see that the vertex, instead of being at 0, 0, has been shifted to 6, 0. So that's 6 units to the right. Okay, so I can check my answer by plugging in a point. So what happens when I plug in x equals 5? The answer should be 5/4. Absolute value of -1 is +1, and I do get the correct value out. Okay, do I make my shot? So it says that my goal is to get to this point, which according to the graph is at 10,5. Okay, so I want to know, does 10,5 lie on the path of this function? So let's substitute that value in. So when x is 10, I want the output to be 5. So we simplify within the absolute value first. Absolute value of 4 is still 4. And 5/4 times 4 is 5. Okay, so yes. All right, so for problem 2, it tells us the speed in miles per hour, but then you notice later the units are seconds. So we need to use the feet per second, not the miles per hour. Okay, so 2 seconds, I'll do that on the x-axis. And then 88 feet per second. So I basically want to count by 88. So I'll count by 22, I guess, since that goes evenly into 88. Okay, so it reached me at 2 seconds. So at time equals 2 seconds, the distance was 0. So 1 second before that, it was 88 feet away, and 1 second after is 88 feet away as well. And then at the beginning of the problem, 2 seconds before, it must have been 88 times 2 is 176 feet away. And same thing with 2 seconds after. Okay, so I can see this one's another absolute value function. Okay, so to write the equation, well, I know the slope from just doing it. I know that 88 per second, this slope is 88. And then how much did the graph get moved? It got moved 2 units to the right. So since there's a horizontal translation by 2, I shift the graph by 2. Okay, problem 1. Okay, so plan A I'll do in blue. $29.95 per month and 10 cents per text message. Okay. Okay, so 10 cents per text message. So I'll convert 10 cents to decimal. And then since this is happening over and over, every single text message is 10 cents, this gets multiplied by the variable. And then there's a single constant fee of $29.95. Okay, so then plan B. This one has a basic fee of $90.20 and unlimited text messages. So that means it's a flat $90.20 no matter what X is. And then plan C. This one cost a flat $49.95, but then also 5 cents, which is $0.05 per text message. Okay, so plan B is just a constant $90.20. So let's see. So that'd be somewhere around here. And since its slope is 0, it's just going to be a single horizontal line. Okay, no matter how many text messages you send, it's a constant cost. So let me just label these. These are the number of text messages. And then this is the cost in dollars, or the total cost. Okay, and I can see from the equations that these plans are all linear. And I can tell because of the constant additive rate of change, or constant first difference, means the same thing. Right, that means that the first text message costs the same as the 10th text message, which costs the same as the 100th text message. Okay, so back to plan A. This one starts at $29.95, so about here. And then this goes up by 10 cents every 100 messages. So I'm gonna skip to get another data point. I'm gonna pretend, what if I send 900 text messages? Okay, so 900 times 10 is $90 from the text messages alone, plus $29.95 would be $119.95. Okay, so something about right here. And then connect up those points, because again, I know it's linear. All right, and then lastly, plan C. So this one, if you send 0 text messages, you pay $49.95 per month. And then to get another data point, let's see what happens if you send 900 text messages under plan C. All right, so 900 times 0.05 means you spend $45 on text messages alone, plus the $49.95 flat fee means you're paying a total of $94.95. So a little bit above here. So actually my plan A point should have been a little bit closer to here. Okay, so let's connect up plan C. Okay, All right, group C. So bacteria culture triples in size every 7 hours, and initially there's 8,000 bacteria. Okay, so at time 0, there's 8,000. After 7 hours, it's 3 times that, so 8,000 times 3 is 24,000. Another 7 hours means it triples again. 24,000 times 3 is 7,200. Okay, but we want to know a function which describes this. Well, first of all, this function is exponential. We can see a constant multiplier or constant ratio. Again, this was times 3 times 3. So one tricky thing here is that the x's aren't counting by 1s, they're counting by 7s. So our initial value is 8,000, and because we're tripling, this is times 3. But then the time, again, it takes not just 1 hour to triple, it takes 7 hours. So you have to take the number of hours and divide by 7, right? Because in 7 hours, it triples once. In 14 hours, 14 divided by 7, it triples twice. All right, so here, the key thing is reducing. So the amount of caffeine should be going down. Okay, so the initial value is 330. So at first we have 100% of the caffeine. So it says it gets reduced by 10%. So that means there's 90% remaining, which in decimal form is 0.9. So that will be our constant ratio. And then this happens every hour. Okay, so over here, if you decide to stop bowling in the middle of the game, you are still charged for the whole game, which means that it gets rounded up. So this is clearly a step function. Okay, this first one specifically is a ceiling function. Okay, so you get charged a flat $15 no matter how many games you bowl, but then each game costs you $4. But then again, since part of a game counts as a full game, that means that your input x gets rounded up. So we do the ceiling function. Okay, so what would this look like? Well, maybe a table of values would help. Okay, so 0 games, you still pay $15 for the shoes. Half a game, they charge you for 1 full game, so 15 for the shoes plus $4 for that game. 1 full game, again, 15 for the shoes, 4 for the game. 1.5 games, they charge you for 2 games, so 4 times 2 is 8, plus 15 is 23. 2 full games, 2 times 4 is 8, plus 15 is still 23. Okay, so we have 0, 15, 0.5, 19, 1, 19, 1.5, 23, 2, 23. So I can see I have a solid dot on the right side of each little step, which means the left side should be the open circle. And I know that pattern continues, so in this case, every 4. Okay, and so on. Okay, so for this one, a dozen donuts, which is 12. So 12 donuts per box. Okay, so first we got to figure out how many boxes Mr. Nguyen needs to buy. So however many students he has, you divide that by 12. But again, he would rather have too many than not enough. So we're going to do the ceiling. And this represents the number of boxes, but each box costs $8.99. Okay, so however many boxes he buys, multiply that by $8.99 to get the total amount. All right, so to graph this, let's make sure we pick some important points. So we should always try 0. So if he has 0 students, well, he wouldn't need to buy any donuts at all. Okay, what if he had just 1 student? Well, for that 1 student, he would still buy a box of donuts. So 1 box times $8.99 per box means he would pay $8.99. Okay, what if he had 12 students? Well, 12 students divided by 12 means he only needs to buy 1 box. So $8.99 times 1 is still $8.99. Okay, so for this one, technically the inputs, the x values, which are number of students, it doesn't make any sense to call it continuous because you can't have 3.6 students. So technically your graph would be discrete. Okay, so the second he gets to 13 students, now he has to buy a second box. So $8.99 times 2 would be $17.98. Okay, and then that would continue on until he got to 24 students, which still only takes 2 boxes to feed. Okay, and then 25 students, now he needs a third box, so $8.99 times 3 is $26.97. Okay, group E. Okay, we see the parabola shape. We know it's quadratic. Okay, so let's see. It says place the vertex of the parabola on the origin 600 feet apart. So if the middle is at the origin, that means the ends are 300 feet on each side. And then 80 feet high. So we know that because the vertex is at 0, 0, not only is the y-intercept 0, but the b is also 0 because there's no horizontal shift. So it's really just a of x, or ax squared. So now we can plug in one of the points. Okay, so if y equals ax squared, and y equals 80 when x equals 300. We just now need to solve for a. So 80 over 90,000 reduces to 1 over 1,125. Okay, so again, place the vertex on the origin. This one is 20 feet across and 6 feet deep. So if it's 20 feet wide, that means 10 feet in each direction from the origin. And then 6 feet. So this point would be 10, 6. This point would be negative 10, 6. All right, so I can use the same strategy. I know this is a general quadratic, but the y-intercept is 0, so c is 0. And because the vertex, the axis of symmetry, I could say is 0, x equals 0. That means that b must be 0 as well. So just ax squared. And then I'm going to plug in the point 10, 6. Okay, so 6 equals a times 100, which means that a equals 3 over 50. All right, function f. Let's see, so if your dog is 15 pounds and under, she charges a flat $35. Okay. If it's between 15 and 40, she charges $40. And then if your dog's over 40, it's $40 plus 2 per pound. Okay, so just from my quick sketch, I can tell this one is piecewise. Okay, so write a function. Okay, so it's a flat $35 if your dog's weight is between 0 and 15, including 15. It's $40 if it's above 15, but below and including 40. And then if your dog is over 40, she still charges you the $40 plus $2 for each extra pound. Okay, so again, $40, but then plus 2 per extra pound. But then you want to remember that you're not counting the first 40 pounds of your dog. Like if your dog is 41 pounds, you're only counting that 1 extra pound. Okay, so instead of just x, it'll be x minus 40, because again, the first 40 pounds are already paid for, but each extra pound is 2 extra dollars. Okay, so this last piece, if I distribute it out, I get 2x minus 80. So if I simplify this bottom equation, it becomes 2x minus 40. Okay, so sketch a graph. Well, I already did that, but okay, so from 0 to 15 is the first important part. This is all $35. From 15 to 40 is $40. And then 40 on up, you pay $2 per pound.